When you want to send a message to a friend who lives far away, your message doesn't go straight to them. It jumps through lots and lots of routers on the way. And these are basically the most important machines on the entire internet. So let's see how they actually work. Every router has a choice to make when forwarding traffic. Give it to router A or router B. And it knows that because of something called a routing table. We simplify the concept, but the idea is that on the left we have the destinations with ranges of IP addresses that are linked to routers on the right. In our example, on the front of the data packet is an IP address. That IP address is in the range of 142.250.0.0, and that IP is linked to router B. So now, the router knows where the IP is headed and sends it out to router B. But why are there IP ranges instead of single IP addresses? That's because there are billions of them, and listing every single one would not be practical. IPs that are similar to each other are usually physically near each other in the network, so they all head in the same direction. There are two main types of routers, core routers and edge routers. We were just talking about the core router. They're the backbone of the internet. They handle the traffic of the whole internet, and they're mostly hosted by big internet companies, your ISP, for example. Their routing tables are massive, hundreds of thousands of entries, because they have to know where everything out there is. On the other hand, we have the edge routers. We all know and love them. They're the ones hosting the internet in our homes. And their job is not to forward traffic like the core routers do. They're the interface between your local area network, that's your home, with the internet. The edge router keeps its own little list, every device in your home. Your iPad, your phone, your computer, each one written down next to its address. Every device you own is on that list, but the last line isn't one of your devices. The default gateway at the bottom is associated with the router. We will later find out why. Now, those device addresses are a specific kind of IP. Because there are actually two kinds, public and private IPs. A public IP is your address out on the internet, unique in the whole world. Anyone out there can reach you through it. A private IP only works inside your own network. Your devices each have a private IP, and those only mean something inside your home. And here's the thing, public IPs are limited. There aren't enough for every device on the planet. So your whole home shares one single public IP, the one on your router. Let's make an example now. Say your phone wants to open YouTube. A couple of things have to happen first. The phone looks at YouTube's IP and sees it's not on its own home network, it's somewhere outside. And a device can't reach the outside on its own, so for anything that isn't local, it sends the packet to one fixed address it always keeps, its default gateway, and that gateway is just your router. The router takes it and sends the request out to the internet, but under its own public IP, not the iPhone's private one. YouTube replies to that public IP, so the data comes back to the router. So the router checks that packet, looks at its small list, 192.168.0.12, that's the phone. So now the router sends that package to the phone. To sum it up, edge routers connect devices like your phone with the internet, and core routers route that traffic through it. They're the backbone of the internet, passing your data from network to network until it reaches the other side of the world and back. Short note, if you like the explainer style of this video, please subscribe. It would help a lot. Now back to it. Now let's look at the edge router more in detail, because it's not one device, more like 6 of them underneath. When you want to reach something on the internet, we learned that the edge router connects your home network to it, and that's true, but there's one key piece we skipped. The edge router isn't actually on the internet itself. It first has to get there, and that's what your ISP is for, your internet service provider. Your edge router connects straight to your ISP, over a fiber line for example, and from there, the ISP routes your traffic through the internet over the core routers. But here's the thing, when data is coming back from the ISP to the router, the signal coming in on that line isn't something your router can read directly. It's raw light or electrical pulses built to carry data over long distances. So the router acts as a modem. It takes that raw signal and turns it into the ones and zeros your devices and router actually understand. Say you want to copy a file from your desktop to desktop 2, but how does it get there? Both devices have an IP address. That's how everything on a network is addressed. So the file gets put into a data package and the desktop writes the goal IP, the one desktop 2 has, on the package and sends that package to the router. The router looks at its table and it sees that the IP is associated with desktop 2. Now, here's something to clear up first. Logically, it's correct to have an IP and a device associated with one another, but technically, it's slightly different. What's really there is each device's MAC. But what's that now? A MAC address is a unique code, 6 pairs of letters and numbers. The first half says who built the device, the second half is the device's own ID. The MAC address is baked into a device, like a phone for example, and unlike the IP, it never changes. So the router sees the IP belongs to the second desktop's MAC. But it already had the IP, so why does it even need the MAC? Because the IP isn't really part of the device. It's more like a sticker the software slaps on when the device joins the network, and it can change. The MAC is the device itself. So it sends the package to the second desktop. The router knows where desktop 2 physically is because the first time it joined the network via a LAN cable, the router remembered which port the LAN cable connected to. Wi-Fi works like this. Your router sends out a radio signal, a wave that ripples through your whole home. But on its own, that signal doesn't actually do anything. It's just a steady ripple. So the router tweaks the wave in a set pattern. One kind of tweak means a 1, another means a 0. Your phone's antenna catches the wave, reads the tweaks, and rebuilds the original 1s and 0s. And it works both ways. Your phone tweaks its own wave to answer back. When a device connects to a network, it shows up with no IP address. So the first thing it does is ask the router for an address. The router looks at its IP address table, and the table has a fixed range of IP addresses. It starts at 2 because point 1 is already reserved for the router itself, the default gateway. And now it sees that 0.2 is free, so it takes that IP address and hands it over to the phone. So now the phone has its new IP address, and the address in the table flips from available to taken. So no other device ends up with the same address. But now let's imagine this. The phone leaves the network. A new device joins, and now the same cycle repeats. And if that kept happening, you'd run out of IPs. So let's look at our example once again. When the router assigns an IP address to a device, it comes with a clock on it. The router only lends it out. That's the lease, usually about a day. Now let's see what happens when the device leaves the network. The slot frees up and drops back into the table, ready for the next device. And if that new device doesn't leave the network, it renews its IP halfway through the lease. In our example, after about 12 hours, it gets renewed and the timer goes back to a day. So that's how the lease time keeps the table from filling up. Old addresses free up before the router runs out. As we learned, when a device wants to access the internet, the IP gets swapped to the public IP every device shares. And NAT makes that possible. But there's a question that gets raised. What if two devices want to access the internet at the same time? First, NAT switches both addresses to the same public IP. But now both carry the exact same address. How would you tell them apart? That's where the port comes in. The router assigns a port number to each device. 5001 for the phone and 5002 for the desktop. And you can think of a port number as a virtual number that gets added to IPs to recognize certain packages or data. So now, both head out as the same public address, just on different ports. When the replies come back, the router looks at the first data package and sees that port number 5001 is assigned. The router knows that this port number is assigned to the phone's public IP and switches that address back to the private one, same with the other package. Now the data can flow to the right devices. Imagine this. A hacker wants to hack your device, so he sends malware to your PC. But to reach your desktop, it first has to get past the router. And that's where the firewall steps in. It just blocks the connection. It knows what to block because of inbound versus outbound traffic. Now picture this. When you want to access the internet, you send a data package to the internet and the reply comes back. The firewall knows that that data came from the local network first, so when the reply shows up, it lets it right back in. That's outbound. The hacker is the exact opposite. He never sent a request, so when his malware hits the router, the firewall sees it's from the outside and shuts it down instantly. And that's one of the most important pieces of network protection there is. To sum it up, anything you asked for flows freely. Anything you didn't never gets in. Now let's do a quick summary of everything we just learned. The core routers route the traffic through the internet. They're hosted by big internet companies and they are the backbone of the internet. And they have big routing tables because they have to know where everything is. The edge router is the interface between your home and the internet, and most home routers have 6 more components built into them. That includes a modem. It translates light pulses to and from the internet service provider. A switch that remembers MAC addresses in a network. Wi-Fi that transmits information through radio signals in a set pattern. DHCP, who organizes IP addresses in a network and hands out IP addresses to devices. NAT is what changes private IPs to public ones and assigns port numbers to devices when leaving the local network. And finally, the firewall that blocks dangerous inbound traffic. That's how the edge and core routers work. Keep in mind, everything is a bit simplified, and there are even more types of routers out there. I hope I explained this video good. So please like and comment and watch the next video. Bye.